All right, let's talk about something that's happening right now behind the scenes on almost every network you use. We're going to pull back the curtain on this invisible, kind of secret process that keeps our digital world from falling apart. And it's a wild story because it's all about how networks stay in sync and how sometimes the absolute smartest thing a computer can do is just take a pause. So let's make this real. Picture this, because I know you've been there. You change your password on your work computer. Then you immediately walk over to another machine, try to log in, and nope, access denied. You're thinking, what gives? I just changed it. Why wasn't it instant? Well, the answer is actually a super clever piece of engineering, and that's what we're digging into.
Okay, to get why that delay happens, you gotta understand the process working in the background. It's called replication. And really the best way to think about it is like a digital chain reaction. One tiny change kicks off this whole sequence of events. Now, the technical term for this, and stick with me here, is intrasite replication. Sounds kind of complicated, right? But it's not. All it really means is making sure all the main servers, we call them domain controllers, that are in the same building or campus, are all singing from the same song sheet. They all need to have the exact same up-to-the-minute data.
So, where does it all begin? Well, every story has a starting point. When you make that password change, it happens on one specific server first. That's our hero, the source domain controller, or just source DC. It's the very first domino in the line, ready to tip over. But here's the cool part. How does this source DC know who to tell? It's not just screaming the update into the digital void, hoping someone hears it. No, it's way smarter than that. It has a little black book, a contact list. Technically, it's an attribute called reps2, and it's literally just a list of all its replication buddies, exactly who it needs to ping when something changes. Think of it like its private group chat for urgent news only. And this whole thing is like a two-step dance, and this is really important. The source server doesn't just force feed the update to everyone else. Step one, it sends out a little polite notification, just a tap on the shoulder saying, hey, I've got something new for you when you're ready. And then step two, the other server, the partner, has to actually reach out and say, okay, I'm ready, send it over. This is key. It stops the source server from just overwhelming everyone else with data they might not be ready for. Okay, so that all sounds pretty simple, right? A change is made, a notification goes out, the partner asks for the update. Easy. But, and this is the twist, this is where things get really interesting. The system, on purpose, introduces a pause. You heard that right. That little delay you feel when your password hasn't updated yet, that's not a bug. It's not the system being slow or a laggy. It is 100% intentional. It is a feature, baked right into the design. The network is literally programmed to take a breath before it starts spreading the news. And man, this just flips the whole script on how we think about performance. It's a perfect example of smart system design. The goal isn't just to be fast. It's not about raw, breakneck speed. It's about being smart. It's about making sure communication is manageable and stable. And that little pause, that's the secret sauce. Now, this waiting around isn't just some random thing. It's all controlled by two very specific timers. They're called notification delays, and you can even tweak them. These two little timers are the secret ingredients that keep the entire network from grinding to a halt. So let's break these two delays down because they each do a very different job, but they're both absolutely critical. So you've got two types. First, the initial delay. Think of this as the waiting period before the very first server gets notified. Then you have the subsequent delay. That's the little pause in between notifying each server on the list. So one pause at the start and then a bunch of little pauses along the way. Let's zoom in on that first one, the initial notification delay. Why does it exist? Well, imagine 10 different people make a change on 10 different servers at the exact same second. Without this delay, you trigger what's called a replication storm. It's a digital flash flood of traffic that could choke the whole network. This initial pause acts like a traffic cop, staggering the start times, turning that potential tidal wave of data into a nice, orderly, manageable stream. All right, so what about the second one, the subsequent notification delay? This one is all about protecting our original server, the source DC. See, without this delay, it would tell all 10 of its partners, hey, I have news all at once, and then bam, it would get slammed with 10 requests for data at the exact same time. It'd be totally overwhelmed. So instead, it tells one, waits a few seconds, tells the next one, waits a few seconds. It gives the source server a chance to breathe and handle each request calmly, one by one. So you've got this really smart, elegant system of pauses. But here's what makes it even more clever. It's not rigid. It's not a one-size-fits-all kind of deal. The rules, the length of these delays, can actually change depending on the network itself. Yeah, the length of these pauses isn't set in stone. The timings are actually variables, and they can be completely different based on how the network is set up. So what kind of things change the timings? Well, for one, the operating system of the servers. A network running on, say, Windows Server 2003 has different default delays than an older one. Even the functional level of the whole network, which is kind of like its overall tech generation, plays a huge part. The point is, the system is smart enough to adapt its own behavior. And all of this, it really brings us to the big idea here, the fundamental balancing act that this whole system is built to handle. It's that classic trade-off between going fast and staying stable. So let's circle all the way back to that first question. Why have these delays at all? Because pure, unfiltered, instant speed would be total chaos. The system would just be flailing, constantly trying to drink from a fire hose of updates. These pauses are the system's way of taking a breath, of pacing itself, so it can actually stay stable and do all the other important jobs it has on its plate. And that, right there, is the thing to remember. This whole thing isn't about technology being slow. It's about technology being smart. It's this beautiful, elegant solution that finds that perfect sweet spot, making sure updates get out fast, but not so fast that they crash the whole system. It's speed with intelligence. So I'll leave you with this to chew on. Now that you see how a delay can be a feature, not a bug, where else do you see it? Think about that little buffer when you start a video stream, or the pause before your phone finds a Wi-Fi signal. How many of those little moments of lag that we complain about are actually the systems being smart, protecting themselves, and making sure everything runs smoothly? It kind of makes you look at the world a little differently, doesn't it?